Given the implicit function x cubed plus y squared equals negative 4xy, so that function's been drawn over here to the left. It's in green. And what we're going to do is find the derivative. And using that derivative, we're going to find the tangent line at negative 5, negative 5. So that blue dot is negative 5, negative 5, and the red tangent line is the one we're going to use. And we're going to end up using this tangent line to approximate a point close to negative 5 at x equals negative 6. So the first thing we want to do is we want to implicitly differentiate this so we can get the derivative y prime. So doing this, I'm going to differentiate this implicitly. So 3x squared plus 2y, and then we need to make sure we add on the y prime for chain rule equals negative 4. This is a product, so I'm going to do 1 times derivative of x is 1 times y plus x times the derivative of y, which is y prime. And then I want to rearrange this and solve for y prime. So I'm going to group my y prime. So I end up with 2y times y prime. The negative 4xy prime becomes positive 4xy prime. On the right-hand side, I end up with negative 4y. And then the 3x squared becomes negative 3x squared on the right-hand side. Solving for y prime, I need to factor first. So y prime bracket 2y plus 4x. Okay, so that's going to give me the coefficient. And I'm going to solve for y prime by dividing both sides by that coefficient. So y prime is equal to, in the numerator I get negative 4y minus 3x squared. In the denominator is 2y plus 4x. Okay, so there's my derivative, my implicit derivative. Okay, so that's part 1. Part 2 asks to find the tangent line at point negative 5, negative 5. So that involves finding a point and a slope. So we have the point. We need to calculate the slope. To do that, we're going to use that derivative. So we get y prime at negative 5, negative 5. I'm going to plug in negative 5 for x and y. So negative 4 times negative 5 is going to give me positive 20 minus 3 times negative 5 squared. That's going to be 75. In the denominator, we're going to end up with 2 times negative 5. So that's going to be negative 10 plus 4 times negative 5. That's going to be negative 20. So the equation of my tangent, or the slope of my tangent line, m, works out to be negative 55 over negative 30. Negative over negative is positive slope, so we're going to end up with, taking out the common factor of 11, of 5, we get 11 over 6 as the slope. So then the equation of the tangent line, now to avoid mistaking it with the y, that is the y of the function, we're going to call this L. So the tangent line, L of x, the slope is going to be 11 over 6, x minus negative 5, so it's going to be plus 5, and then minus 5. And that's our y coordinate. Okay, so that reflects our x and y coordinate plus the slope of negative or positive 11 over 6. Okay, so the third part then is use that tangent line to approximate the function value at x equals negative 6. That involves plugging in the negative 6 into our equation. So we're going to say this. We're going to say that the y value at negative 6 is going to be approximated by the L value at negative 6. Okay, so then plugging in L, negative 6 into there, we end up with 11 over 6, negative 6 plus 5 minus 5. Okay, so that works out to be, it's going to be negative 1 times 11 over 6 minus 5. Simplifying that expression, we're going to end up with, we need a common denominator, negative 11 over 6 minus 30 over 6, and that's going to give us negative 41 over 6. Okay, so the y-coordinate is at negative 6. Okay, at negative 6, we're looking at some point right about here on the green line, and you can see that the red line is pretty close. Our approximation is going to be, on the red line is negative 41 over 6. That's about negative 6.8, 6.9. So that looks about the right spot, somewhere around here at negative 6.9, 6.8, somewhere around there. Okay, and that's our approximation. The red line is going to approximate the green line, and it looks about the right spot based on our diagram given.